What's up guys and welcome to this video about proper error handling in Android. In this quick video I will show you an approach how you can properly handle your errors, be in full control of all the different exceptions, define own exception types, map them to custom errors to show the user always what's going on. And this is also a very general approach which can be applied in every project. And I think there are too less videos about handling errors because all the videos assume that everything works always. But in a real world project, this isn't the case. There are a lot of exceptions that can be thrown, and also sometimes you need to define own exceptions. And then to have a clean code base, you need a proper error management. And in this video, I will show you the basic approach of such a proper error handling and give you one or two examples, and then you can build upon them and apply this in your own projects. First of all, we want to create our custom error class, and I think there's no separate package structure required here because we will only have like 5 or 6 files at the end, which is not too complex. So we can do everything under the root package. Here we will create a new sealed class called custom error. In this class, we can define different error types, which then represent something that we want to show in the UI to the user in case this specific error occurred. So first of all, we have an object called no network connection. This will then inherit from custom error. And there's no message required here because the object name itself says everything, and therefore we don't need a data class here in the sealed class, and an object is fine here. Then we have another object, for example, and I will call this simply another specific error, which also does not require a message because the name says everything here. This could be invalid login data, for example. And our last error type will be a data class called general error, which can then be used, for example, in the else branch of a when expression, or if you just catch a general exception without knowing the specific type, then you can make use of this general error. This will also have a message, because then the message allows us to be more specific, because the name general error itself does not say too much, so we can also pass a message. This will also inherit from custom error. And of course, this class can then be expanded with further specific error types and all that stuff. All right, okay, the next class we want to define is a custom exception class. This will be a sealed class as well. We can call this custom exception. This custom exception class takes a message of type string, which is optional and null by default. And then we can inherit from exception the standard exception class from Kotlin and pass the message. The reason why I think this custom exception class is beneficial is because it allows us to throw exceptions in a very easy way. For example, if we are in the data layer and then we check manually for network connection before we make a network request, and we want to show the user that there is currently no network connection, then we can just check on the network connection with network connection manager and so on. And if we don't have network connection, then we can simply throw a no network connection exception, which will be our custom exception type. Of course, we could also try to somehow utilize the custom error types inside of a function where we do a network call, for example, but normally you want also to return some normal values in case everything works. And then you need to create another object where the custom error is included and the normal return type. And this custom exception allows us to simply call throw, and on a layer above in the view model, for example, we can simply catch this exception and map this to a custom error there. In here we will now define some example exceptions, for example the no network connection exception, and then we will also use the same like we have in the custom error, the another specific exception, which also inherits from custom exception. And of course, you can also define additional exception types which aren't here in the custom error types, or you can also create custom error types which are not represented in the custom exceptions here. In my case, I just do a one-to-one mapping here. And this will also illustrate you the function we define now, map to custom error, because here we can define a logic how such an exception gets mapped to a custom error. And then we can just call this map to custom error in case we catch an exception, a custom exception, and then we have only one line of code later in our view model and we get the right custom error. But you will see how everything works when we defined this custom classes, and then maybe it gets more clear and you will see how clean this approach is. This will return a custom error. We will say return when, and take this as the basic, is no network connection exception. Then we will return a custom error dot no network connection. In case if the current instance is another specific exception, then we want to return custom error dot another specific error. And we will also define an else branch, which is not necessary here because with these two cases we covered everything that's possible. But in the future you maybe define additional objects above, and then you forget something to define here, then this else branch is a good practice. And here we will say custom error dot general error, and we will pass this dot message. Okay, alright, these two classes are the heart of this proper error handling, and you will see how powerful these classes are. I will make a quick example, and of course the real power of this approach only gets shown when we have a big application and we can make use of these two classes everywhere in our code base. I hope it gets a little bit clear why this is such a good practice and how clean it makes our code and how much flexibility and power it gives us to handle different errors and also scale the error handling. Alright, okay, let's create an example repository class where normally a network request is done with an API interface or something like this. And we will just simulate this because this is only about the custom error handling and not about network calls or something like this. For that, we will create a main repository class. In here, we will define a suspend function, fetch data. Normally, network requests or database requests are done in suspend function in case there's no flow involved. Here we can say throw exception, because here we can't really generate an exception which occurs naturally because we don't do anything here. So we need to take care of this manually. Here we can simply say if throw exception, then we can throw custom exception dot no network connection exception, for example. Normally, of course, you would check above here in this line, in line 6, if there's currently a connection to a network, and if this is not the case, then you would throw this no network connection exception. Or also if you return something from the API which you don't like, then you can also throw an exception based on this. And then we can simply say return test, and we also need to define a return type. So nothing special here, only to show you how this could potentially work. And then we go to our root package again, define a main view model, because normally the view model make use of a repository for network or database calls or something like this. So we will kind of simulate this here. We will create a class called main view model, which inherits from view model. Also not necessary here, I think, this view model inheritance, but well, let's keep it like this. Then we will have a private val main repository, and we will simply generate this main repository inside the view model. Of course, in a real-world application, you would do something like dependency injection for that. And then we will have a var main error by mutable state of, and this will be our custom error type, custom error, which is optional because it's not necessary that there is an error occurrence, it's optional. And for the default value, we simply pass null, and this will be a private set so that it can only be set inside the view model. Then we will define a function get data, and here we will say view model scope dot launch, because we need to invoke a suspend function. For that we need a coroutine scope. And now I hope you see the beautiness and also how powerful this approach is. And I will also expand this error class after we defined the error handling in the UI, how it could potentially look. And I hope it gets clear, and I hope you can see why this is so powerful, because we don't even need to change the view model if we add 6 or 7 or more additional custom error types. But let's define this here. we will say try. And in this try block, we will do our normal network requests or database requests or whatever. And we will say, well, result is equal to main repository dot fetch data. And here we can then say, okay, you should throw the exception. We set this to true. And in this catch block, we can then catch our own custom exception. And this result will not get filled in case there is an exception. So whenever this main repository fetch data throws an exception, we go immediately to this catch block. And in this catch block, we should, of course, start with the more specific exceptions because they get executed sequential. First of all, we want to check if this exception is a custom exception. If this is a custom exception, then we will say our main error is equal to E, which is our custom exception, map to custom error. With one line, we could potentially handle like 10 or 20 errors and save them in this main error. And on the UI later, we can observe this state, this main error state, and show the user different texts, different snack bars, or do some recovery strategy or something like this. And in case there is no custom exception, in case this is a standard exception like IO exception or something like this, then we can of course also catch this, and we can say here E is exceptional, so the general exceptional, and for that case we can say main error is equal to custom error dot general error, and for the message we pass the localized message in case this helps us or helps the user to see what error exactly occurred. And if we would switch this, if we would take this catch block above like this, then this will always be executed even though it's a custom exception because they get executed sequentially. So it always starts with the more specific exception, and at the end there should be the general exception types. And with two easy understandable lines of code, we have mapped all the exception types, or we could map all the exception types to our main error type, to our custom error type. Of course, you could also be more specific in this section for IO exceptions, for example, and use this general catch block at the end. But yeah, you can apply this to fit to your own needs. And the really important thing here is now that our UI, where we can observe this main error, only needs to know about this custom error type. And all the mapping, all the exception mapping, and also you don't even need exceptions to use this custom error types. For example, if you have a function check input data and you get string A and string B, and these are username and password, for example, then you could check if A is empty or B dot is empty. And if this is the case, then this is an invalid input. Then you could say main error is equal to custom error dot invalid input. Something like this. Of course, this invalid input needs to be defined in the custom error, but this is just one more object in there in the sealed class. And so you can always make use of this custom error in case there's an exception or in case you make an error check for yourself. And again, the custom exception is more like a tool which helps you to throw errors easily inside the data layer, for example, and which can then be mapped to our custom error type in the view model, like here. And the custom error type is the dependency or the class which is known by the UI, where the UI can then decide what to show to the user when a specific error occurred. And a question which you could potentially ask, I think, is what's the case if I'm not only interested in showing different UI related stuff, and I also want to do additional error handling? How should I do this? Then you can do something like this. You can create a private function, process error. And this function can then be invoked here, process error, like this. And in here, you could then check on the main error type like this and make a when check if this error occurs, if this error occurred or something like this. And then you have an additional line of code. Okay, but maybe you could also do something like this. Or you could also have a finally block which gets executed in each case. Doesn't matter what actually happened above, and you can say something like this. And if there is one specific error, like is no network, like custom error is no network connection, then you could just do some process here. And if the other errors don't require any processing, then you could just do it like this, or I think you could also write unit. And yeah, this is how this could potentially work in case you want to do additional work when a specific error occurred. All right, okay, the last thing we want to do is to observe the error on the UI and show different UI elements depending on the error that actually occurred. For that, we can just go to the main activity. Normally you have different screens and so on. And we'll also say a private val main view model, which normally should be injected by Dagger Hilt or something like this. But for this case, this is fine. We can remove this preview stuff and default generated stuff. And in here, we can then get reference to our error state. For that, we can say main view model dot main error. And in the, or we can also put this outside this theme. Or no, let's leave it like this. Doesn't matter. When you actually do this, then you would need to structure this a little bit better, of course, in your composables and not in the main activity. And then we can check if the error state, which only is a potential value, is not equal to null, then we know that there is an error occurred. And then we can do a when expression, error state, and in case there is a custom error dot no network connection, then you can show a text like check your internet connection and is custom error dot another specific error. Then you could also show some kind of text or something like this. And of course, if you want to check like 7 or 10 errors or something like this, then this list gets really long. But for that, you can also create a separate composable which only returns the composable which you actually need. And then you can also invoke this here with a one-liner. And let's just do this for the sake of completion. We can here write specific error occurred. And in case this is the only thing you want to check, let's also remove this typo. Then you can also just apply a else case. And for this else case, you can say text an error occurred. You always need to decide how much granularity you want to apply for your error checking. And in case you are not interested in this another specific error, then you can just remove this if you are only interested in the no network connection. And in all different else cases, you can just return this text composable if you think this is enough. But error handling should be always as precisely as possible, I think, when it helps the user to continue in your application. Alright, okay, the last thing I want to show you is what happens if the custom error and the custom exception classes getting bigger. Here we can, for example, use another error type for an invalid input. Invalid input inherits from custom error. And then we can make use of this invalid input error type. And in case we want to show an additional error to the user, if we want to be more specific, then we just add an additional when branch and say your input is invalid, like this. So not that difficult. Okay, of course, we need to change this to invalid input like this. And let's also assume that we have an additional exception object. Let's call it invalid user data return from the network, for example, inherit from custom exception. And if this is the case, if the case is invalid user data return and we don't have a custom error for that, then we could either create a custom error for that in our custom error class, or we could just say it's okay if this error occurs, then we want to just say this is then a custom error, general error. For the message, in this case, we pass null. And then you can see inside the view model, we don't need to adjust anything because this mapping is already invoked inside our view model, and everything runs behind the scenes. If we also want to do or we want to also represent this arrow with a custom arrow, then we can say invalid user input. Okay, don't take this names as a reference, just for the principles here. And we can then go to our custom arrow, and we want to say invalid user input. Then we have another custom arrow mapping here. Again, in our view model, there's nothing we need to change. And in our main activity, we can then copy and paste this one more time. And this time we will say invalid user input. And yeah, I think you get what I mean. We have so much flexibility here without messing up our code, because everything is in here in this custom arrow and custom exception. And sometimes in a repository class, you need to throw an exception, or you make just use of the custom arrow without an exception, like we had in our view model. Well, in the function I defined before, I already deleted this. Yeah, okay. All right, okay, this was it for this video. I hope you enjoyed it and you could learn something. And I also hope that you can apply this in your own projects in production code, because I think this keeps your code very clean, is very flexible and very scalable. All right, thanks for watching. See you in the next video.